Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administration exam. In today's video we're going to be talking about how we configure Firewall with IP tables. Now there are two methods, whether you're using CentOS 6 or Ubuntu or Debian. The service is called IP tables and is managed appropriately with that name, whereas CentOS 7 and Red Hat 7, it is called Firewall D. We happen to be running on a CentOS 7 box right here, so if we look for a system CTL status on the Firewall D service, we'll find out that that is indeed running, and we can see whether IP tables is currently running with any rule sets already applied to it by doing an IP tables -L, which it is. So we've got a number of different rules applied to our various zones. Now if we look at our client machine over here, we're going to ping the server IP address of 135 and see that we do get a response. So we're able to not only ping the machine, but we're looking at using the IP address for that particular server as our default gateway. So everything that we do right now on this machine is going through that firewall. So now that we're looking at the firewall, there's a couple of things that we want to do. Let's go to etc sysconfig, and from within here there's a couple of different configuration items. So for example, typically in etc sysconfig there will be a file called iptables or iptables-config that has the rules and the configuration for IP tables. So in the case of saving rules, it would normally be stored in a file called iptables. So we need to look at the iptables config and see what, if anything, is turned on. So we look in here, we see iptables modules, modules unloaded, save on stop, save on restart. So here's where we want to look at. So when we stop the firewall, this is saying don't save to the iptables firewall file if it's stopped. If it's restarted, don't save on restart. And then this is saving a counter for saving the number of times that it's been saved. So if I wanted to be able to preserve the state of the firewall rules on stop or start once I've completed testing, then I would change these iptables save on stop and restart to yes, which would then create a file with all the iptables rules in it. We're going to manually create that so that we can see what it looks like, and then we'll run through the commands for saving and restoring those configurations. On production servers, I have a tendency to turn this on. In the case where we're doing testing or development servers, I will generally turn this off because you're going to be doing more flushing of rules and changes of rules than you're going to want to save. And again, this is not intended to be a complete tutorial on IP tables and firewalls because that could easily take up a course in and of itself. We're going to show you how to manage the rules and what the different options mean and how to apply them and serve as a jumping off point for configuring your firewall and your rules from within your network. So as we said earlier, if we do an iptables-L, we see everything that's configured for our server right now in each of the zones, any rules that happen to be applied to our zones. So what we want to do now, we could, if we wanted to flush rules from any particular zone, so if I do an iptables-L and I grep for input, input has some policies accepted for it, or some policies applied to it. What I could do is I could do an iptables-F for input, and then I could grep for input again. You'll see how these rules that were applied to this particular zone are now gone. So I've flushed the rules for the input chain or the input zone and any policy rules for it. And that's just an easy way to clear out the rules because then I can change the default policy. So right now because my input policy is set to accept, I could change by default. I could simply change the default to reject for the entire input zone. I can only change the default policy for an entire zone if I've cleared out all of the rules. So this is a way to clear out the rules so that I can apply a new blanket policy to that particular zone. In our case, what I want to do is if I want to start from scratch, which means I want all rules to be flushed out of all zones, I can do an iptables -- flush. And now if I do an iptables -L, you'll see a much simpler display, which is all of the zones, no references or rules applied to any targets. So I've got kind of a clean slate to apply any rules that I want. So if you remember earlier, we were able to, from our client, ping, let's go ahead and clear this, ping our firewall, 1.135. Now, doing a ping of a firewall is many times disabled, and there are two ways of disabling something. You can either reject it or you can drop it. Whereas rejecting it will simply respond with a rejection message, so they'll actually get a reply. Dropping means it'll ignore it. It actually drops and doesn't respond at all. So from a firewall perspective, externally, it's much more common for you to drop traffic than it is to reject it. Internally, you may want to reject it. So let's talk about if I wanted to drop the traffic for ICMP, or let's reject the traffic, because that way we'll actually see a response, and then we'll go back and drop it as well. The syntax for creating a rule for us is iptables -A for add, the zone that it applies to, in this case the protocol that we want to filter out, which is ICMP, the interface in interface, and then the interface name, which is EMP0S3 for a CentOS 7 system, at least on my network adapter, -J, which is what you want it to do, and we want it to reject the traffic. And then if I do an iptables -L and I grep for input, what I should see, or I grep for reject rather, is I should see a rule that says reject ICMP traffic from anywhere to anywhere with port unreachable. And that translates to, from my client, when I do a ping, then I get a destination port unreachable. However, that doesn't mean that the IP is unreachable. That's simply meaning that I do get an actual response that says that the destination port is unreachable. Now, what I might want to do, for example, so let's do an iptables --- flush, and let's redo that rule, and in this case, let's just say drop, and make sure that it is applying itself by grepping for drop. We're saying drop ICMP anywhere to anywhere. Now when I go back over here, now when I ping that IP address, I get nothing. I get no response. I get no, it's like that IP doesn't exist. And this is on a local network, so I'm getting no broadcast message whatsoever from that IP, no response through ICMP. That's typically what you'll see from an internet perspective. If you have an IP, it's not uncommon for ICMP traffic to be turned off. So let's look at another rule. So one of the other things that we can do is we can decide that we don't want input or output for HTTP for this server. We don't want it to answer for HTTP input. We don't want it to answer or allow HTTP output. So what we can do is we can add an input rule and an output rule that will disable that from happening. So let's say iptables -A input -P TCP, so any protocol, and I could just do a -- protocol as well, but we can do a -P TCP. We can do a source IP of anything. So in other words, any network address I don't want to, or it applies to this rule. The source port, I'm going to say 1024 to 65.535, because those are generally the ports that from an endpoint perspective will open up to port 80 here. All ports have to translate. -D to 00, so the destination is any network address, on destination port 80, and then reject. And then I repeat that exact same rule, more or less. Output -p TCP-S -p, not tcox. Let's try to spell everything right. Output -p TCP -d port 80 source port 1024 65535 -j reject. And now what I should see is if I do, for example, going out, if I do a links, let's do a telnet localhost 80. Had connection refused. See, we rejected it, so we get a connection refused. This is outgoing, so this applies to our output. So if I do a links, http www.cnn.com, unable to connect to remote host. Now if I do a local host, I get making an unable to connect to remote host. Now, to verify that this is actually being applied to our system, we'll flush the output. But let's go see if we can use our client to connect to our IP address on the localhost web browser that happens to be running. 1.135. Unable to connect, can't establish a connection. So let's go back over here. Now if I just want to flush the IP table, so IP table -- flush, and now when we clear our screen, then if I open up a browser to my local host, I get the 403 forbidden, but the web page will come up here, which is my testing web page. And I can also do my CNN page that I did before, which also comes right up. And now if I go over here to my client and I simply hit try again, my test page comes right up. So I was able to control, using my firewall and the rules that I applied, I was able to control how and where my packets are being filtered through my firewall. Now if I go all the way back to what I did before, which was to configure the ICMP so that it rejected the interface, and now I've got a rule that I want to be able to save, but I don't necessarily want to save it when I exit. And in this case, if I just do a stop and then I do a restart, that rule isn't going to be there anymore. So for example, let's do a IP tables -L and let's grep for reject. Now if I do a systemctl restart on firewall D and run the same command, you'll see that this particular rule has not been applied. Port unreachable versus host prohibited. Now if I want to apply it, so I'm going to do an IP tables -, flush. To flush my rule set, I'm going to reapply my reject rule, grep to make sure it's there, and now what I want to do is I want to back it up. So I need to do an IP tables -save, and then etc sysconfig, because this is the default location for it, and then IP tables. And now if I do a cat on IP tables, that rule in all of the particular zones applies, including the one that we just added here. So it sets up all of these zones, creates and commits all of these zones by default. This is all the rules from IP tables. And then at the very end, once it's done all of that, it executes a -A to the input zone on the interface here with this protocol, and it rejects those ICMP ports as unreachable. Now, for example, if I do an iptables -- flush, and I see iptables -L and grep reject, I don't see anything. So if I want to restore my rule, I can do an iptables -restore and then redirect the input to etc sysconfig iptables. Now if I do an iptables -L and grep for reject, my rule is now reapplied automatically. And when you apply a rule, it's applied immediately. So you don't need to restart iptables in order for your new rule to be applied. In fact, unless you've set this to save on exit or to save on restart, you'll actually wipe out the rules that you've added. So your rules are immediately applied, which is one of the reasons we're using local VMs, because if we inadvertently added a rule that filters out SSH traffic, or we did a blanket reject on rules with a typo, we would be hosed from a remote perspective, because accessing a remote VM, we don't have access to the console. If we can't reset the IP tables and it's not a physical server that we can hook up a console to, then we're kind of out of luck. So as you're learning IP tables and how to set up and restore and work with the rules from within IP tables, I recommend that you do that locally in order to reduce your chance of making a mistake that will cause your server to need to be completely rebuilt. So for configuring our firewall and some basic IP tables rules for rejecting, dropping, and accepting traffic internally and externally, both on the server as well as on a client, that's all there is to it. My name is Terry for Linux Academy.